Hey guys, what's up? So in this video we will learn about logarithm and the involvement of logarithm in the time and space complexity, big O. So log or logarithm, simply said log, common complexities क्या हो सकते हैं? It could be O of n, O of n square, O of n 1 by 2, there is O of n root n. Basically these are common complexity, but there are more complex complexities wherein we involve logarithm as O of log n or O of n log n. These are called complex complexities. Okay, anyways, so what is log again? So log basically could be said as inverse of exponentiation, or simply said inverse of power. Okay, what do I mean by that? For example, this is log base, this is called base, log 8 base 2. Okay, log 8 base 2 gives 3. So if you are logically equipped, so you can see a pattern that means if we do 2 to the power 3, we get 8 2 to the power 3. So basically you see that what used to be the answer becomes the power. That means basically it is the inverse of exponentiation. That is, this 3 will go this side and this 8 will come this side. This thing will get reversed. This is getting reversed. So basically log is nothing but it is an inverse of exponentiation or inverse of power. Okay, so this is understood. So in a general term we can say log base 2, the answer or the value is equal to the exponent, that is 2 to the power exponent gives the value. So we can simply say log base 2 value equals to the exponent, equals to the exponent. Like this was the exponent, 3 was the exponent, 2 to the power 3 gives 8. Okay, so the common ones, the common types of logs are binary. That is binary, you understand, log with base 1 with base 2. Base 2 we saw. It's not necessary that the log will have a base 2 all the time. It can have other bases, like it can have a base 10, it can also have a base e. But for simplicity we will just in our case we will take log base as 2. And the cool thing about 2 is that you can even omit 2. These two things are same only. These log base looks nothing, is not 1 here, is 2 is hidden here. If somewhere it is written log simply, that means here 2 is hidden. You can write it like this, or you can omit 2. These are all same thing. Okay, so let's get a bit more into it, and let us say in simple words, log of a number roughly means the number of times you can divide that number by 2 before you get a value that's less than or equal to 1. What does it mean? That means, for example, you had a number, okay, so you divide it once, it is 2. For example, let's say there was a number 4, okay, so you divide it. So according to log, the log of a number is roughly the number of times you can divide a number by 2 before you get 1 as a remainder. Okay, let us consider here. For example, I had 4 and I divided it by 2. So that means the number of times I can divide 4 before I get 1 or less than 1, less equal to or less than, that is less than or equal to 1, that will be the log of that number. Okay, so we can divide it. 2 1s are 2, 2 2s are 4. So what is the remainder here? What is the remainder? Remainder is 0, and 0 is less than 1. So we should stop dividing now. So that means, how many times did I divide this? I divided it twice. 2 times I divided it, or 1 time. Oh sorry, how many times I divided it? I divided it once, like one stroke, it finished, it killed it, right? So let us see. So log base 2, 4. Okay, we have what should give 4 with a base 2? It should be, so how many times did I divide this? Oh sorry, I divided it twice, not 2 1s are 2, 2 2s are 4. Twice I divided it, right? Yes, that's why 2. We'll get 2 more examples. So this is what I learned today. So as I told you, I'll come up with an example to explain what I just said in the previous part, or previous few seconds back. So if you have a number 8, so we divide 8 by 2 once. So you divide it with 2, we get 4. When we again divide 4, we get 2, and we again divide 2 with 2, we result to 1. So here we should stop. So our thing is, we should reach 1 or less than 1. Okay, ठीक है, 1 or less than 1. You should reach 1 or less than 1 after dividing it with 2, and you should count down like how many number of times it does it. So as you can see, it divides 8 3 times in a clean way, and we get 1, right? So it's easy. Log base 2, we can omit 2 as I told you, or you can write 2, oops, and we'll get 3, because 3 is the number of times it is divided by divided by 2 to get to 1. Our aim is to reach 1. How many number of time you have divided it with? So this was a good example. This was a clean example. Let's take another example which is not so clean. Hopefully recording. Yep, it is. Let's take 25. 25 and divided by 2 once, we get 12.25, and we again divide it with 2 as per the rules, and we get 6.125. Again divide it, since we have not reached 1, less than 1, so we keep dividing. So we get 3.0625. Again divide it with 2, we get, again divided with 2, we get 1.53125. Is it less than 1? Or is it equal to 1? No, it's still less than 1. But you can see this case we have reached here is, we know the result will not be 1. It will be less than 1. It will not in a clean way divide, the result will not be clean. It will be less than 1. So anyways, so in a rough way, 1, 2, 3, 4, 5. It says when we divide 25 5 times by 2, we get a number less than 1, but we wanted 1, right? Yeah, so that means there is a value somewhere between 4 and 5, okay, which actually divided 25 and resulted to 1. So anyways, so we can say it could be, so you can simply say approximately equal to 5. Log base 225 approximately equal to 5, or you could say there is a value between 4 and 5, as I told you, 4 and 5, which will result to 25. Okay, so the answer is 4.26. Okay, log base 25 is 4.26. Anyways, I'll come back to it. If it is wrong, I don't know, maybe 4.26 it is. Anyways, so log base 225 results to 4.26. So where are the places where we will be needing log thing and this logarithm case? So logarithm will be used in searching algorithms. In the searching algorithms, we will be dealing with time complexity of searching algorithms. Those searching algorithms which are efficient, and sorting algorithms, like efficient sorting algorithms, uses logarithmic values, as well as we'll use it in recursion. None of these topics we have learned right now, and recursion, I really don't know what it is till after years. Anyways, so in recursion we'll deal with logarithmic values related to space complexity, not time complexity, with space. Got it? So let me see you in the next video. Hey guys, so let us look at this chart here. This is a chart which will demonstrate like the time complexity, or simply a complexity in terms of big O. That is the worst case scenario. It's like how will your algorithm behave in terms of space and time when the input size, let's say n, reaches infinity. So anyways, so you can see here we have O of 1, that's the constant runtime, and here a constant space O log n. So if you have it is said that if you have a algorithm whose complexity anyways, whose complexity is O log of n, that means it's a good complexity. It's really good. It's like kind of similar to a flat or a constant complexity. That is O of 1. It is similar to that. The other complexities as well, that is n log n, which is bad as compared to n square, but it is not as bad as n square. You can see that. Look, it is not taking that much time with increasing value of n, right? As n reaches infinity, and when n reaches infinity, the n square case. So the time taken is slightly less. Here it is, when compared to O of 1, it is like O of 1 is O of 1 is best complexity, you can say. Then and log n is a good, better, best, right? So it is somewhere between, let's say, better and best. So O of 1 is best and better is n log n. No, is it? No, best is O of 1 and better is n log n. Got it. So this is all about it. So n log n is also a complexity, log n is also a complexity. This is all about it.